So today we'll talk about the data tools and services that Sentinel team provides. Currently, the tools and services are used in many use cases. For example, we are using them to monitor the healthiness of the network, especially after a major network upgrade or protocol changes. And the data set is also used by other teams like FEM or Lotus to monitor the network growth, the minor activities, or for the storage providers to track their deal state changes. So here are a list of Sentinel services that we offer and maintain. The first one is Lily. It's a core technology that we use to extract blockchain data from the Filecoin blockchain. And we have Sentinel Tick that collects Filecoin pricing from multiple exchanges. We have Sentinel Location that maps the miner's geographical location from the Sentinel-derived data. And we have Filecion that creates archival-grade snapshot on a daily basis that will be used by our batch processing data pipelines. And last is Mercury. It's a new service that the team provides to offer a unified data access layer. So here's a high-level service architecture. So you can see on the top side is the real-time ingestion flow, which contains Sentinel Tick, Location, and Lily. They insert data into our timescale database in a near real-time fashion. And on the bottom side is the batch processing workflow. So it starts with the Filecion, generating daily archival snapshot and get consumed by our data pipelines and insert the data into BigQuery as well as timescale DB. And the data in our data storage will be used to power alerting, dashboards, and used by our developers and analysts. So next, we will deep dive into Lily, and I'll hand over to our main developers, Terry.
Hi, everyone, I'm Terry. And Lily is a service to capture the data from the Filecoin network, particularly from the Lotus. And Lily can get a basic data like blocks, messages, receive, and active state. Moreover, Lily can also get some crucial data like internal transaction messages and smart contract interaction, storage deals. And Lily provides the real-time analysis and the historical backfill abilities. And it can watch the trend for real-time data, also can work for the historical data. And Lily support the several export formats such as SQL and CSV. And here is the Lily architecture. Lily uses several core libraries like the Lotus, IPLD, and Actors. And to index the tip set, Lily will call several processors. Each text have a corresponding processor that capture the data in parallel. Once they're done, the model exporter will serialize the data to the destinations, like a CSV or a Postgres. And Lily generates three major types of data. The first one is trend data. Lily extracts the data from the state and block. And the following chart is the total amount of the value of gas data in each tip set. And second one is the state change data. Lily capture the active state change. And this chart is represent the power change in each epoch. And this was derived from the sector state change. And the last one is the state dump data. Lily will periodically fold dump the active state. And this chart shows the history of the balance within the EVN, ETH account, and the placeholder. They also have more interesting FEVN reality data and chart. For example, the FEVN transactions, EVN balance, and the money flow between the contract and the miners. Yeah, that's all for the Lily.
Thanks, Terry. So people might be wondering, like, it looks all great, but what if I don't want to run Lily on my own? How can I access the data? So first, we make our BigQuery dataset public earlier this year. So anyone with a valid Google account and billing information can access our Lily dataset. The catch is that you'll be responsible for the data processing and the network charges. And second, Mercury is a new data access API layer that the team provides. There are two goals. Like one is to provide like unified layer, and the second is to help our analysts and research scientists to use a tool that they're most familiar with. So we offered a Python client which will automatically convert the result into data frames. So here's an example how the Mercury API works and the result that we're getting back in JSON format. And with a couple of Python code, you can easily run any query against our BigQuery dataset and get the result back in data frame format. How do I get access? So feel free to sign up for beta at mercury.rest. Currently, we only support BigQuery dataset, but the timescale DB data will be supported soon. And here's our team information and the code base and Slack channel. Thank you.